This video is from my earlier course, back when I was building out these ideas. The fundamentals I cover here are still solid, but the frameworks have evolved significantly since then. Head to systemthinkinglab.ai to see how this turned into a full course series. Hello and welcome to our next lesson, Putting It Together, a fundamental approach to system design. Let's get started. So, in this lesson, we'll go over how we will introduce a new way of approaching system design through case studies. These case studies and a technology-agnostic building block approach is formulated to inspire that senior-level intuition for junior engineers. Intuition is built when seeing the same building block used in different case studies, and you see the strengths and weaknesses, the ways that you can employ them into future system designs that are robust, but also you fully understand it as well, and to develop that end-to-end intuition for junior engineers. So, a recap from bits to systems. So, remember, everything in our digital world breaks down to zeros and ones. And at the lowest level, data is either stored as sequences of zeros and ones, and we use storage units to represent that, or processed instructions that transform or utilize those zeros and ones. We represent that here as task units. So, task units and storage units combine to make these fundamental building blocks that we're going to talk about throughout this lesson. These components or building blocks can be servers, databases, or well-known constructs, and each building block exists to fulfill a specific purpose in the system. Our goal, though, and I'll continue to repeat this, is to develop intuition over specifics. The purpose of this course is to develop intuition and not to memorize implementations. Implementations don't give you that intuition to face new problems. Repetition gives you the ability to hear something and repeat what you've said without understanding. We are focusing on understanding the end-to-end aspects of a system as a junior engineer. By understanding the building block concept, you can reason about any system regardless of technology specifics. This intuition helps you adapt, compare, and even switch technologies when necessary. And this happens a lot. You have a system, and then years go by, something new comes out. This can be very, useful for your system. Understanding fundamentally what your system actually needs and what it's actually using gives you the ability to swap one technology or the other, because you can find a new technology that's better at doing the actual thing that your system needs, as opposed to saying, hey, I have this technology and that's what it needs to happen. This happens more often in industry than you would think. So understanding exactly what your system needs using this building block method enables you to future-proof your system and evolve it in the future. So, moving forward, the next step, 15 case studies. So just like you do in the field, the approach for this lesson in this course is that instead of saying, hey, here are all the building blocks, learn them all and you'll be great. Instead, we're trying to develop, again, not memorization, but intuition. We're going to just jump into different case studies, and each case study will be things that you've used every day. Blogs. Have you been on a blog? How do we design a blog application? Social media. Are you on any social media applications? How you can build a simple one. Video streaming systems, online learning systems. We're going to go through 15 of these case studies, and as we go through, we're going to introduce building blocks and show what a system design of that would look like. Each case study will present requirements and what we want to build, and then show how to compose building blocks, remember task units plus storage units, to meet those requirements. So seeing many examples builds stronger intuition, just like in real life. In essence, what this course is trying to do is not so dissimilar to what happens in real life. The idea is that a junior engineer goes in, they learn, they join in, they have these particular tasks they work on, and as they work on systems over the years and things of that nature, they develop that senior level intuition, and then they understand how to build systems. What this is basically doing is that, hey, could we take that process and condense it and accelerate it? How about we just go through a number of case studies now in this building block method that you can understand more readily than in the field, and you might be able to advance your career, advance your understanding a lot faster than you normally would. The case study method is a very tried and true method. Business schools, employed all the time to give them scenarios of scenarios of what you would do if you're, running a business and had, this issue or that issue. By going through these hypotheticals and working those out, you develop that intuition without having to actually manage a multi-million-dollar company and have to do it live. We're basically moving that same concept to engineering. And that's essentially the sense of this course, is to do that. So the next step is to go through these 15 case studies. Now, first though, we start with requirements. Real world system design starts with defining requirements. You determine what the system should do, who uses it, what it stores, and what tasks it performs. And the case studies will simulate this process. You read the prompt, understand the scenario, identify key needs. This is what happens in real world. In the real world, there are real problems that the system that you're trying to design and build is trying to solve. But you need to understand what the problem actually is. So that's going to be defined in the case study. Then we're matching requirements to building blocks and eventually a whole system. Once requirements are known, we combine building blocks to meet them. We introduce building blocks, though, as a combination of task units and storage units. And every time we introduce a new building block, we'll go aside and talk about what storage and task units are, comprised of, like a combination of those two things, build that building block so you intuitively understand each building blocks that we introduce. Over time, you'll see patterns. I'll just say, oh, remember building block from case study 3? We're going to have it in case study 6, and so on and so forth. Certain building blocks appear repeatedly to solve common problems. This is one of the intuitions we want to give to you and to ready to develop. So, again, not about the best design. There are many valid ways to design a system contrary to popular belief. You'll be surprised about some of the designs. Yes, there are some designs better than others, sure. But again, the goal of here is not to say, oh, look at how X and Y company did this amazing design doing the most specific thing and it's so amazing. That's great. That's awesome. That's not the purpose of this course. The course here, the focus is on understanding the fundamental reasoning process. What do you need to store? What tasks you need to perform? Utilizing the best building blocks to architect your system. Seeing the commonalities between building blocks. Doing this over and over again. Gaining that intuition so that you have your own intuition that works for you, that helps you and give you the tools and the understanding that you can face other system designs, and then you can be inventive yourself. The goal of this course and to develop these designs is not to show you the 15 best designs and you should memorize them again. This is not about memorization. It's about understanding. The goal is that if you fully understand all the building blocks here and fully understand how we built them to satisfy these 15 case studies, one thing I am very certain that you will have a lot more confidence and a lot more ability to look at systems in your day-to-day work and understand what's happening end to end. And then we'll also equip you with the ability to design future systems, understanding these things. So that is the goal of this course. It's identifying patterns in systems. After examining multiple examples, you'll recognize repeating patterns. Common building blocks appear in different contexts. Similar trade-offs and considerations emerge regardless of domain. This is the biggest secret. I don't know if it's a secret, but it's the biggest advantage that senior and staff and principal engineers have. It's because they've seen so many things. They look at a new thing, they're like, oh, it's this, this, and this. And you wonder why. It's like, oh, it's my experience. The goal is, though, I'm going to use this case study method to take all that experience and give it in a way that junior engineers, that have the ability to employ a lot earlier in your career. And that's the purpose of this course. So building that long-term intuition. So study all 15 case studies to develop a deep, flexible intuition. Refer to the provided guide under this video listing for building blocks in a real-world technology counterpart. So in this video, I'm actually going to list all the building blocks that we're going to use in all 15 case studies. This is not an opportunity to go in and memorize them, but it's to look and see all the different ones, what they're comprised of, like what do they do, and also, and I'll keep this up to date, what technologies now employ those things. And you may be really surprised. about how many, one technology might be able to be, multiple building blocks could be implemented by a single technology. Something to think about. That again, it's not about the technology when it comes to system design. It's about what you're using it for. And if you understand it, and that's what the building block method forces, it forces you to really understand what you're using something for and have that be the basis of your design, not the technology. So over time, you understand what each technology really provides and how to swap or adjust building blocks as needs evolve. So your next steps, approach each case study with an open mind. Just open your mind up, especially if especially you have some experience and you've, let's say, built one of these things before and you're like, oh, they're not doing the wrong, they're doing it wrong. They didn't do it the way that I did it at X and Y company. Again, the purpose is not to say, ooh, this is the better design of what you experienced. Your company could have the better design anyway. The point of these case studies is not, again, to have the best design, but to give you that intuition by showing how all of these applications can be built and how can be designed using this building block method, that you fully understand all the building blocks and understand how they connect together. When you have that, then you'll gain intuition that will help you in the future. So again, the key, and I can't repeat this enough, is to focus on the building block concepts, rather than think about which specific technology implements those building blocks. This is the key. This is the key. And if you think about it, this is why data structures and algorithms are so powerful. When we talk about data structure, we're not talking about a particular implementation. We're not talking about a particular computer or computer architecture that's being saved on. We're talking about hash tables. We're talking about trees. We're not talking about specific tree, how it's designed. When we're talking about algorithms, we're talking about, okay, there's graph algorithms, there's search algorithms. We're talking about generically. This is just taking that concept another step further into modules and components, because again, especially when you're an engineer, you're a senior engineer, and so on and so forth, you'll notice that there are groups of these functionalities that happen over and over and over again. And once you understand that, then it will really supercharge your growth as a junior engineer. So with each example, grow your intuition, making you more confident and versatile in system design. So thank you so much, and I'll see you in the next one. This was from my original course on system design for junior engineers. Since then, I've refined and expanded everything you just saw into the full system thinking the AI era course, using these same building block principles across 15 plus real case studies. If this resonated with you, the link is in the description.